Hey, this is Tony from College. In the previous video, we used an equation that described the relationship between a hen and how many eggs she would lay per year. We said that the hen laid 200 eggs a year, and we described this relationship by writing the equation H equals 200E, where H stands for the number of hens and E for the number of eggs. So in this video, we're going to do a couple of more examples. Let's say we have a family where children receive a weekly allowance that is equal to $1.25 per year of age. Let's use the letter W for the allowance and the letter G to represent the age. Now we need to write the equation that we will use to find the allowance based on the age of the children. This equation will be W equals 1.25 times age. Now let's say that in the family there are two children, Joyce, who is 7, and Chris, who is 10. So for each of the children, we will substitute the G for their respective number, 7 and 10. The Joyce equation then is W equals 1.25 times 7, which gives 8.75. So Joyce gets a weekly allowance of $8.75. Now for Chris, we have W equals 1.25 times, and here we substitute G by the respective number, his age, which is 10, and we get $12.50. Note that it is useful to distinguish between the equation that describes Joyce and the equation that describes Chris. To do that, we can add a subscript to their corresponding allowance. In this case, Joyce's W becomes W subscript J, and Chris becomes W subscript C. We are still using a single equation, which is this one, but applied to two different cases. And to distinguish between the cases, we just add the subscript. But this is the same equation. This is just to keep track of which case we are talking about. What we just did is find the allowance, W, based on the age of children, meaning the age was given. We have the ages here. We knew the age of each child before solving, and W was something that was not given. It was the value that we needed to calculate, the thing that we had to solve for. Now let's imagine that the question is asked differently. Instead of saying Chris is 10, so how much is his weekly allowance? We could have said Chris gets $10.25 weekly. What is his age? Right? So instead of giving the age, we give the allowance, and the question becomes, how old is this child? So in order to answer that question, we just need to reorganize the equation. Instead of writing this here, we would have the G on one side alone. G equals W divided by 1.25. These two are fundamentally the same equation. It's just a reorganization of its terms. Here we have W that stands alone because this is what we are looking for. We are looking for what is the allowance when age is known. And in this case, we are looking for the age while knowing how much allowance the child is earning per week. But it is the same equation. It's the same equation written in two different ways. These are not two different equations. So let's just write here that Chris gets $12.50 per week. And the equation we use is this one. Again, the value that we are looking for stands alone on one side and all the rest is on the other side. So G is unknown, his age is unknown. We have G equals W. We know it's equal to 12.5, $12.50. And we divide this by 1.25, which means that G equals 10. i.e. for an allowance of $12.50 per week, Chris's age is equal to 10. Now, you might be asking yourself why in one case we multiply and in the other case we divide. One way to understand that is that when we go from, in the first case here, from knowing the age, so we go from age, what we know, to what we don't know, which is the allowance. So from age to allowance, in the first two cases we did, it's the opposite as going from allowance to age, as we just did for Chris with the $12.50. So if we multiplied when we go from age to allowance, when we go from allowance to age, it means we need to divide. A bit like if you take 2 and you multiply it by 5, you get 10. If you want to get back to 2, you're going to divide 10 by 5, right? So moving in one direction, you multiply. If you want to undo it, you divide. All right, let's do one more. Let's say that a team of event promoters who sell tickets for an event get a commission of $2 per ticket. So let's say we have Nelly, who sold 45 tickets, and we have Grace, who sold 38 tickets. And let's say that we also have 2 other cases. One of them is Riz, and we know that he earned $78. And we also have Tanu, who sold a total of $104 of tickets. So for the girls, we know how many tickets they sold, and for the boys, we know how much they made. So in this case here, we go from tickets to commission, and in this case here we will go from commission to tickets. So again, it's going to be 2 versions of the same equation. To write our equations, we're going to use T for tickets and we're going to use C for commission. Here we know the tickets, so it means we have to solve for the commission. So commission is what is going to stand alone on one side. Commission is equal to 2 times the number of tickets. And in these cases, we know the commission and we are looking for tickets. This means we have to solve for T. That's going to stand alone on one side. T equals commission divided by 2. These 2 things here are the same equation written in 2 different ways. If we solve for Nelly, let's say we have C subscript N, we get 2 times 45, meaning her commission is going to be $90. And for Grace, we get this. And for the cases where we know the commission, let's take T for Riz, which is going to be equal to C, which is 78 in this case, and we divide it by 2, which gives us 39. So now we know that Riz sold 39 tickets. And for Tanu, we take T and we put the subscript T for Tanu. C is 104. When we divide it by 2, we get 52. Tanu sold 52 tickets. All right, in this video, we dove in a bit more depth into writing algebraic equations with 2 variables. The main takeaways are, 1, that we want the value that we are solving for to stand on one side alone and all the rest on the other side. Second takeaway, that is a direct implication of the first one. Depending on which of the 2 variables is known, we write the equation differently. So we have 2 ways of writing an equation, depending on which of the variables we are looking for, we are solving for. And the third takeaway is that for a given equation, if we want to differentiate between 2 instantiations, 2 cases of the same equation, we can add a subscript. This is just to identify the case to which we are applying the equation.